Okay, this is still notes on radicals, but this time we're going to be talking about higher root radicals and simplifying those. Now, make sure that you're not giving decimals for these. That's not what we're doing. We're not asking to, how much does this equal decimal form wise. These are irrational numbers, and so irrational numbers, you can't round them. So be careful with that. Radicals with root index other than 2. So if you look here, this is a cube root. All right, so this is bigger than 2. The root is 3. The cube root of 64 is 4. So we say the root index is 3. Okay, it's third root. 64 is the same as 4 times 4 times 4. Right? 4 times 4 is 16. 16 times 4 is 64. And so this is why the cube root of 64 is 4. Because what number times itself 3 times gives me 64. We want to know what number multiplied by itself this many times, the index, 3 times, is 64, the radicand. 4. So the cube root of 64 is 4. To have a cube root, the exponent must be a multiple of 3. Okay? So in other words, I could rewrite this here as 4 to the power of 3. And so then the cube root of 64 is 4. I can take 2 groups of 2 cubed. Well, what is 2 cubed? Like, what are we talking about here? Well, let's look down yonder. I could take 2 groups of 2 cubed. Well, isn't this one group of 2 cubed and another group of 2 cubed, right? So this is 2 groups of 3. This is my index here. Cube root of 64, again, is 4. When I'm looking at 2 groups of 2 cubed, well, what does 2 cubed equal? This could be, like, they're saying I got 2 cubes, and I want the cube root. Well, 2 cubed is 8. 2 times 2 is 4 times 2 is 8. So this is an 8, and so is this. And this becomes, oh, look at that, the cube root of 64, because 8 times 8 is 64. But look, if I take out groups of 3, this comes out as a 2. This comes out as a 2. Both 2's are on the outside, and that equals 4. And we've been saying the cube root of 64 is 4. Again, I could break this down to its prime factors, right? 2 is a prime number. 2 times 2 times 2 times 2 times 2 times 2. I showed you how you could do that on the calculator. And I've got 2 groups of 3, right? So this one group of 3, this one right here, would come out as a 2. And then this second group would come out as a 2. And again, 2 times 2 is 4. All right, let's practice with some of these. The square root of x squared. You could also think of this as a ratio, power. If this is going to write correctly for me, divided by the root. Think of something that rhymes with power, like flower. The flower is in the top, and the roots are in the ground for our plants, typically, okay? So it's power over root, power over root. So here's my power. My power is my exponent, right? This is 2, and my root here is also 2. So if I think of this as power over root, this is x to the 2 power over the root 2. This is x to the power of 1. So guess what? The square root of x squared equals x. The square root of x to the power of 6. You know, I could think of this, you know, a bunch of different ways. I could write this as x squared, x squared, x squared, right? So I've got 3 groups. I have 3x squared. That's going to come out. That's going to be equal to what? X to the power of, you know, this is going to come out as an x. This is going to come out as an x. This is going to come out as an x. And what's x times x times x? That's x to the power of 3. I could do power over root. I could do x to the power 6 over root 2 and get x cubed. Either way, my answer is x cubed. All right, I'm going to put little separators here. If I do power over root, this thing equals x, right? This is x to the 3 over 3, or x to the 1. I could think of this in terms of the cube root. Now be careful when you're simplifying these. If it's cube root, you have to have that little 3 in there. Sometimes this, I've had students, I'll change the color to model. Sometimes I've had students, they write the index first and then they put the thing around it, okay? It's got to be small. It's got to be inside this opening. So be cognizant of that. You can't write it big because it's going to look like 3 times that. You know, you don't want to write it out here big. It's going to look like 3 being multiplied with that radical. So be careful. This one, if I do power over root, this is x to the power 6 divided by 3, which is x squared. Or I can model this in groups of 3. I could write this as x, and I need the 3 in there. Okay, cube root of x, 3x, 3 more is 6. This could also be thought of as the cube root of x being multiplied by itself 6 times. Okay, and I'm looking for groups of 3. There's one group of 3. There's a second group of 3. Okay, and here's my second power. This would come out as an x. This would come out as an x. So either way, it's going to equal x squared. Separate this. Go on. We've got 4 more examples. And then you'll have some practice. If you have questions, remember to ask in class or ask in a meet or post on the homework discussion. You know, if you need like a solution worked out, something you want a quick short little video, post it on the homework discussion so that everyone else has access to it. Now this one here, we're going to have remainder, right? Because 17 doesn't divide, it isn't divisible by 5. 5 won't divide 17. But, I mean, I could rewrite this. You know, this is x to the 17 over 5, power over root. Well, that goes in there 3 times with how many left over? 2 left over. So the 2 left over stay inside the radical. So it's going to look like, you know, x to the, how many times does it divide? You said 3 for 15. And then we've got 2 left over. Now remember, this was 5th root, so you need the little 5 there, and the 2 stay inside. Now we'll see. I'll change the color to green so that we can see when I do it the other way. So I've got the 5th root of x to the power 17. You know, I could write this as what number is divisible by 5? Well, that's 15. And then 2 more is 17. Remember, these have to add up to what's originally in there. And then I could do my power over root. 15 over 5 is 3. So x cubed comes out. This stays in because 2 is not divisible by 5. So this is multiplied by the 5th root of x squared, which we saw up here. It was x cubed times the 5th root of x squared. Okay, so it just depends how you see it, how you look at this and see numbers and see these variables. All right, this one, 1,200 or 1,200. That's pretty big. So we're going to use our calculator. And I want you to get a calculator out. And I want you to do 12,000 divided by 2. And I want you to keep doing it. And figure out how many times 2 divides it till you get a number that is not divisible by 2. So I'm going to get my calculator out. And I'm going to do 1,200 divided by 2. It's still even. Divide by 2 again. It's still even. Divide by 2 again. This is the 3rd time now. It's still even. Divide by 2 again. Now I get 75. So folks, 2 divides this thing recursively 4 times. So I'm actually going to write it as 2 cubed times 2. Right? This is 3 and then 1 more. Okay, so, but I'm not done because I still have times 75. So now it ends in a 5, so I'm going to divide by 5. So divide by 5. It goes. It divides by 5 again. It goes twice. So this is times 5 squared times what's left, 3, and 3 is a prime number. Okay, so if I do 2 cubed times 2 times 5 squared times 3, it's going to equal this number. Remember, this stuff in here has to equal that. Now I want these in terms of powers of 3 or numbers that are divisible by 3 because we know about this power over root. 3 is divisible by 3, so I'm going to keep that as a cubed. B to the 8th, well, I'm going to write that as b to the 6th times b squared. Why? Because 6 is divisible by 3. And then with 2 left over. And then c to the 9th. Well, guess what? 9 is divisible by 3. So I'm going to keep that as c to the power 9. Now I'm going to remove stuff, take it out, right? This is going to come out. This one here is going to come out as a 2. That's got to stay in. This has got to stay in. It's not a group of 3. This 3 has to stay in. It's not a group of 3. Hey, guess what? This can come out, this can come out, and this can come out. Do your power over root. A to the 3 over 3 is a to the 1. B to the 6 over 3 is b to the 2. C to the 9 over 3 is c to the 6. Not 6. Sorry. Not 6. B to 9 over 3 is 3. What am I thinking? All right, so far I got 2ab squared c cubed. What's left? Folks, this and this one, let's underline them. This stays in, this stays in, this stays in, and this stays in. Okay, I'm going to cross the ones off that came out. That came out, that came out, that came out. okay? These got to stay in. So I need 5 squared is 25, times 2 is 50, times 3 is 150. And remember, my index was 3, so I have to have cube root. 150 stays in, and what else stays in? B squared. Okay? Not too terribly terrible. But you have to understand and know how to break it down to its prime factors. Use the calculator to help you. Okay, if a number is even, it's divisible by 2. 2 is prime number. I want to get out as many 2's as I can. All right. This one here is the index is 4, so I'm looking for groups of 4 now. 729. I don't know. Is it divisible by 3? Sure. It's divisible by 3, and I get 243. Divide by 3 again. I get 81. Divide by 3 again. I get 27. So far, I divided it by 3 times and got 27. But guess what? 27 is divisible by 3 again. So I'm going to do divide by 3. That's the 4th time. So now I have a 3 to the 4th. And what's left? Times 9. Well, isn't that times 3 squared? Okay, you don't have to write it as a square if you don't want to, because you know it's not going to come out anyway, right? Which is fine. Now I need this x to the 7th. I need it in groups of 4. So I do have one group of 4 in a 7, and then I have a group of 3, right? Because these have to add to 7. I only have 7 x's in here. This is 7 x's. Just rewriting it a different way so that this could divide the exponent. All right, so what do I get? This comes out as a single 3. This comes out as a single x. And these ones that are uncrossed have to stay in. Keep in mind what your index is. It was the 4th root. 3 squared is 9, and x cubed is x cubed. Okay? Last one, 648. X, y cubed, z to the 4th. I'm going to use the calculator again. Divide by 2, divide by 2, divide by 2, divide by 2. So let's look. 648 divided by 2 is 324. You can make a little stroke tablet if you want. Okay, and that was one time. It's still even. Divide by 2. That's the second time. It's still even. Divide by 2. That's the third time. And I am looking at square root here. So I'm looking for groups of 2. So this was really 2 squared times 2, right? Because it's happening 3 times. So my exponents have to add to 3. Now I've got 81. Well, 81's a square. That's 9 times 9, isn't it? And isn't 9 really 3 squared times 3 squared? Right? So it's 4 times 2 times 9 times 9. That equals 648. All right, x to the power 1. Nothing I could do about it. I can't rewrite it. It's just 1. I have 3 y's. Well, can I write 3 y's as 2 y's times 1 y to be 3 y's? And why do I want to? Because it's square root. Z to the power of 4. I'm going to keep it as z to the power of 4 because this is even and that's even and it's divisible. So now I'm going to cross out what comes out very lightly. Okay, my squares are going to come out. What stays in? This stays in. This stays in. No, it does not stay in. That one comes out. This one comes out. All right, what else stays in? The x stays in, and the y stays in. Okay, so these 3 are going to stay inside the square root. What comes out? Well, 2 squared comes out as a 2. 3 squared comes out as a 3. 3 squared comes out as a 3. Y squared comes out as a y. Z to the power 4 comes out as a Z squared. And now you have to multiply these that are on the outside. So what do I got? 2 times 3 is 6, times 3 is 18. Times y times z squared times the square root of 2xy. Okay, so when it's square root, you're looking for groups of 2. When it's fourth root, you're looking for groups of 4. When it's cube root, you're looking for groups of 3. So you're going to try the radicals worksheet with higher roots. I think that's radicals worksheet number 3. I think so. So again, if you have any questions, you know, ask in class, post on the discussion so that others have access to it. Again, one more time, I'll reiterate what we did with the 648. We did use a calculator and we divided by 2. And when you do that on the calculator, and you don't have to write all this down, you could just write the number of times 2 divides it. But just to illustrate, I'm going to do 648 divided by 2 is 324. And then you're going to divide this again. This 2 comes down. It's part of it. 324 divided by 2 is 162. So there's my 2 times 162. 162 is still even. So it's divisible by 2 81 times. This 2 comes down. This 2 comes down. Okay, here's my 2 cubed. Right? This 81 is, you know, you could go with the prime number first. It doesn't really matter. But I know this is 9 times 9, and I know 9 is 3 times 3, and I know the other 9 is 3 times 3. But don't forget, we had these 2's. Okay, and so if this was the square root of 648, then I could rewrite it as the square root of 2 times that, or the square root of 2 times that, or the square root of 2 times 2 times 2 times 81, or the square root of 2 times 2 times 2 times 3 times 3 times 3 times 3. And I'm looking for groups of 2. That comes out. That comes out. That comes out. And so this one stays in. This comes out as a 2. That's a 3. That's a 3. 3 times 3 is 9. Times 2 is 18. And that was this right here. 18. And that 2 stayed inside. So this was 18 square root of 2. Now, this was me doing it with no variables, okay? But this is just the breakdown and the reason why behind it. So again, if you got questions, please let me know. Remember, I can't help you unless you ask a question. Have a great day.